Another day, another lesson, grade 11 mathematics, geometry, let's do it! So one of the sections that you will always cover in your grade 11 mathematics, or grade 10, or grade 9, or grade 8 will always be geometry. They will always give you geometric shapes and graphs and ask you a series of questions which are always relatively the same thing, and you try and solve it. So I thought, for today's lesson, let's work on a simple geometry problem and go through the basic steps to solve it and answer really simple questions that are money for jam when it comes to tests and exams. Let's get started. So the example we're starting off with today is a simple parallelogram. So in the question, they would have said that A, B, C, and D are 4 vertices which make up a parallelogram. And you can see that the coordinate of A, B, and C has been given, but the coordinates for D and E have not, and P, they've also told you, is the intersection point between the two diagonals of this 4 vertice parallelogram. What I would like you to do is to copy down the picture of this parallelogram into your notebooks before we get cracking on all of these questions. So go ahead, write it out. As we go through answering a series of questions related to this, I'll bring it up on the board again. But make sure you jot it down right now. So the first question they would ask would be, find the equation of BE. So in order to solve this problem, you need the coordinates of B, which is 4 and 8. And the coordinates of E, you don't have it yet, but they've also given you a point that sits on the same line for BE, which is C. The coordinate for C being 5 and 0. So you've got 2 points that sit on a straight line, so you can find the gradient. And once you find the gradient, you can substitute it back in to find the C value. What would the gradient be? M would be equal to y2 minus y1 over x2 minus x1. And let's assume that x2 and y2 is b. Substituting in those values, it would be 8 and 4 minus 5 minus, almost messed that one up, minus 0 minus 5, which would be 8 over minus 1. So the gradient would be minus 8. So now that you've got the gradient, you can find the C value. So y would be equal to minus 8x plus C. So let's substitute in either B or C. The easiest would probably be C. So substituting that in, you're going to have 0 is equal to minus 8 times 5 plus C, and therefore C must be equal to 40. So the equation for the line BE would be y is equal to negative 8x plus 40. And there you've solved the first bit of finding the equation for BE by simply using the coordinates B and C because they lie on the same line. Simple, isn't it? So now that you find the equation for the line BE, the next question that could be posed to you in an example paper or a test would possibly be to find the coordinate of D. But how would you find that? So you don't necessarily know what the coordinate of E is, so you can't directly interpret what D would be. A sort of sits on the same line as D. What could I possibly use out of my toolkit to try and solve this? Well, in the question, they told you that this is a parallelogram. So you know that opposite sides are equal in length. So you know that AB is equal to DC, and you know that BC is equal to AD. So I know that coordinate A, y value, is 4 units lower than coordinate B's y value, which is 8. So that is a difference of 4 units along the y-axis. But knowing that, I know I can use that because of the fact that C is also part of this parallelogram. So if I'm sitting at a y value of 0, if I had to move 4 units down, I would lie on the same line as D. So I would have 0 minus 4, which would be minus 4. So I know the first bit of this is that the y coordinate for D would be minus 4. But I also know to preserve that same property of the parallelogram having equal and opposite sides, I know that the x value of A, which is minus 3, down here, minus 3, and I know the x value for B is 4, over there, positive 4. I know that this distance is 3 units plus 4 units, which would be 7 units. So I could use that same kind of thinking for C relating to D. So I need to move 7 units from positive 5x, from positive 5 on the x-axis, 7 units to the left-hand side, which would be 5 minus 7, which would be negative 2. So I have the x value, great, which would be minus 2. So, using the property of a parallelogram and the vertices, you can now interpret and fill in what the missing value would be for the coordinate D, which would be minus 2 and minus 4. It's that simple. So now that we've solved what coordinate D is, the next question that could be posed to you would be finding out what coordinate P is. But before we go any further, what I suggest you do is to update your drawing with this new information, so that as we go step by step and fill in more coordinates, you'll understand it so much better. So go ahead, I'll give you a bit of time, update the drawing, and then we will do what point P is. So the next thing you're going to do is using the property again of this being a parallelogram and you knowing that AB is equal to CD and AD is equal to the same length as BC. So you know that being a parallelogram, the diagonals must bisect each other. So the length of BP is the same as DP, and the length of the other diagonal of AP is the same length as PC. So knowing that they're equal distance, I could actually find out what point P is by using the midway or midpoint formula that you all know. It's this one over here. Using that relationship, we can now say, okay, what would the midpoint P be between A and C? Well, we could just say the x value, 2, and the y value would be negative 3 plus 5 and 4 plus 0. So point P would actually end up being positive 2 on the y-axis and 1 on the x-axis. As simple as that, because you understood the properties of a parallelogram. If you're unfamiliar with the properties of parallelogram, there's a link in the description that you can have a look at the simple properties of a parallelogram. So the fourth question that could be posed to you now would be, well, I filled in what D was and I found what P is. What's the other thing that I don't know about this question? That would be, what is E? But remember at the beginning of this question, I told you that they said that the line DE runs parallel with the x-axis. So if I know what the coordinate of D is, I already know what the y value of DE is. And I already know that it's -4. So I can already fill in -4 over there. But I still don't know what the x value is for E. But wait, didn't I find the equation of line BE already, which was y is equal to -8x plus 40. So I could substitute this y value back into this equation and find out what the x value is. So let's do that. I would substitute it back in, which would be -4 equals -8x plus 40. And simplifying this expression, taking 40 to the left-hand side, I would have -44 equals -8x. Therefore, x must be equal to -44 divided by -8, which would be 11 over 2. So you can fill that value in for coordinate E. So now that you've filled in the last remaining bit of information, additional off-the-beaten-track question that could be asked to you would be, if this is a parallelogram, could you now prove that it is actually a rhombus? So, knowing the link and the link that I gave you below in the description, how can I prove that this is a rhombus? Well, we know that it has the same properties, that it's got equal sides, it's got bisectors of the same length, but the actual bisectors are perpendicular bisectors of each other. So how would you prove that they're perpendicular? Well, you know that the two gradients are inverses of each other. So let's find the equation or the gradient for AC, and then we find the gradient for BD. So in order to prove that it's a rhombus, you would want to make sure that the product of the two diagonals, or the gradients M1 and M2, would be equal to -1. So let's take A and C as M1. So M1 is equal to 4 and -3, -0, -5, which would be equal to 4 over -8, which would be -1 over 2. Now, M2 must be B and D. So you've got 8 and 4, Y2, X2, and -4, and -2, which would be 8 plus 4 is 12 over 4 plus 2 is 6 equals 2. So what are the results that I got? -1/2 and 2. So what would the product of these two results be? -1/2 times 2 would give you -1. So you've proven that M1 multiplied by M2 gives you -1. So you've proven that the line AC is perpendicular to BD. And by proving that, it is now a rhombus. So understanding the simple relationships of a parallelogram and the defining properties of a rhombus, you could solve for the missing coordinates in this problem. You could prove that the bisectors were perpendicular to each other, and you've easily solved a simple maths problem that could have been given to you in any of your tests this year or your exam papers. Really, geometric problems are money for jam in papers, and it's set out there for your teachers to help you see if you understand the fundamental relationships of maths. If you enjoyed today's video, give us a thumbs up, smash the like, smash the subscribe. We love creating videos for you guys. Everything that we do, we're passionate about, and we want you to learn and thrive. So please give us a like and a thumbs up, and we will continue doing what we're doing. I'll see you later.